Thank you. I'm so happy to have somebody help me. Let's see. All right, I got some more people stumbling in. Let me start off with questions. Anybody have questions from homework problems? By the way, I said I would do this, and I don't think I did because I don't think anybody reminded me. I still need to put up 1.5 scan in the homework. Is that true? Is anybody still have a book coming and needs more scans of homework put up there? Is anybody in that situation? I see somebody nodding their head, but I'm not sure if they're listening to music or what's happening. Does anyone need a scan of the 1.5 homework?
Yes, Professor,
Okay.
because I will receive the book on 12.
Understood. So
Thank
Jeff, please understand that this is not me being an asshole. It's just me knowing my memory. Email me, remind me to do that, please. Please, please, please. Somebody.
Thank you.
Because I'll start teaching and I'll forget every damn thing that ever happened. Okay. Anything from homework, guys? Anything from homework you guys are working on?
I
You don't,
noticed, hey,
Sal?
excuse me, I don't mean to interrupt you. So I noticed what the homework for the August, you haven't unlocked certain homeworks for myself.
Say again, sorry.
So I'm still, you haven't, so in order for me to proceed to the
All right.
homework, I have to.
So Sal, real quick, you got to finish that first module. You got to get that done before you can unlock the homework.
All right.
I'll tell you what, I'm going to go ahead and unlock it for you, okay? And then you can get ahead, but you got to get that first thing done, okay?
All right.
All right.
Are you going to just unlock all the ones in August?
I'm going to unlock the chapter 1 homework for you so you can start turning that in, okay?
All right.
All right.
Thank you.
Yeah. There we go. Chapow. All right. All right, so I guess I'm an optimistic fool, and I'm going to assume the fact that there's no questions means everything's going really well.
I mean, I had a lot of questions for you as I was trying to figure it out, and it would have been a good idea if I would have taken it down then. But I can assure you for next class, I'll have some questions for you so you can help me along with the homework and where am I kind of lost. But
okay. And some of those, Sal, some of those questions that you're going to have might be better in like my office hours or something because you're trying to catch up. So, but either way, you can always ask me during class and I'll tell you if I want to answer it or not. And then you can just ask it in hours. Yeah. Okay.
All right. Sounds good.
Sure. All right. Let me see. A few more people logged in. No questions from homework. So I want to show you something that, is anyone paying any attention? Does anyone know what's happening this year in like November, on November 3rd? Does anyone know what's happening?
The election.
Election, okay. Is anybody planning on voting for the first time? Anybody? Do I have anybody?
Plan on voting. Yeah.
Okay, good. And this will be your first time?
Well, ideally, yes. Like I will be choosing because normally like people would try to tell me, oh, vote for this guy, vote for that guy. Ideally, yes. Like it would be me voting for what I believe in or what the interest that I have. So
yes,
it would
that's
be
probably a good idea. We're not going to go into who you're going to actually choose. And I see Joel is planning on voting for the first time. That is very exciting. And but I'm really sorry. I want to apologize to you. No matter what your political affiliation, I think we can all agree that things are really screwed up right now in general, not just because of the pandemic. But I want to show you something in case, is anybody paying any attention to political forecasts, like what it seems is going to happen? Vu, what's up? Vu?
No, that was an accident.
Oh, okay. I have the power to put your hand down. So let me show you this real quick. There's this website called 538, Very strange name for a website. So if you Google 538, you'll find it. Has anybody ever heard of this 538? I know it sounds like I'm about to try to sell you Amway stocks or not, but 538 is a really well-respected, what do you call it, forecast site. So if you go there, let me take you back. There's our 2020 election forecast. So we're talking about probabilities right now. So I want you to get a little bit of a glimpse into when people calculate probabilities, how do they display it for the general populace? And this website's pretty good about showing just, so if you scroll down a bit past all this business, it gives you this. Now, this is relatively simple to understand. Do you guys with me? Right now, who seems to be more likely to win?
Biden.
Yeah, actually, it says it right there. Yeah. But what's interesting is if you get a little deeper into this, each of these little dots is a simulation they ran based on numbers they've gotten, right? So they have different programming simulations and they simulate it. So 30 times out of 100, Trump win, 69 of 100, Biden won. And I guess one time they tied. Now that would be remarkably interesting. But I don't know if you guys understand what's happening. So they ran a simulation. Has anybody watched football before and they actually use Madden or something insane to run simulations of what might happen in a Super Bowl? Has anyone ever seen that when they run simulations? No? Some of you guys are like, football, no. Okay, fine. It's just an example. So anyway. So I mean, my purpose for this is just to show you how probability is used in the real world and how it's presented to people. Now, they actually go a lot deeper. This is a neat curve. Of course, I'm going to love the shit out of this. I mean, look at this. It's data and it's graph and it's neat. But it basically shows the same thing as up there. And then this one, anyway, I'm not going to get too deep into this. So it's up to you if you want to go there. But this one kind of shows you the bluer it is, the more it's going for Biden. The redder it is more it's going for Trump. And this is the line that you have to cross to actually make it to become president. So right now it looks like the blue is a little bit over, but these are really light blue, meaning they're really close. Are you guys semi with me? And I'm not going to say, you're not going to say anything. I'm not going to say anything about how we feel about this necessarily, right? I desperately try to keep my politics out, although it doesn't always work, especially nowadays. Oh, stop. Sorry, that might have given something away. Blah, blah, blah. And here it gets a little more detail, blah, blah, blah. Anyway, all right, that's enough of that. I just want to show you that because it's a really cool website. I like their visuals. And if you're interested at all, it does a lot more than politics. So they do sports, they do athlete protests, they do all kinds of stuff, right? So it's not just the election. So it's kind of good statistical analysis with really nifty visuals. So I really like that website for probabilities and statistics. Okay, and enough of that. So hopefully that was semi-interesting to a few of you guys. Let me check in one more time because I think a few more people came in. Any other questions from homework before I jump back into section 1.6? I do want to do some stuff together with you. All right. Let me see here. All right, guys. I was thinking about making a poll. There's a cool website too where they make a word cloud out of things. I don't know if that would be something we would be interested in. Are you guys doing okay at this point in the semester? Are you, I appreciate that you are surviving, at least in this class. I have no idea how your other classes are going. You doing relatively okay out there? This is not the best forum to ask that question probably. Because if somebody's, I remember I would come into class and I'd say, hey, how was everybody's weekend? And somebody would go, it sucked. I'm sorry. So I don't want to bring back bad memories. Okay. So let me, oh yeah, Lauren, I agree with you. I think I've made it clear that I never, ever wanted to teach online. I never did. I had a roommate who was a teacher and she taught online and I watched her go insane. And I said, I don't want to ever do that to myself. But now it's the only way. So yeah. So anyway, all right. So I agree with you, Lauren. I also hate online. Yeah. Well, even when I'm on ground, which I love that phrase. Do you guys realize the opposite of online is on ground? And I always think in my head, what's the opposite of on ground? In the air? Is it like a Mary Poppins thing where you're all floating in the air teaching class? Even when I'm on ground, on campus, I record my lectures and put them up on YouTube. And that's why I got videos going back to 2011 or whatever it is. Exactly. I do the same thing. I always at least double the speed when I'm watching something, because most people, especially debates, they talk like this. So I can speed up. Talk like this. That's better. Me, I kind of talk fast a lot of the time. I don't know about that. All right, so let me share the book with you. I'm going to do a few things together with you. Not out of the homework. Where did I want to go? Let me go ahead and share this with you. Oh, crap. I don't want the Microsoft Store. Go away. All right. Share that. Pop. Here we go. Is this where I want to be? Yeah, so this is what we did yesterday. Here's where I want to be. All right, good. Don't look, you get sick. All right, so look at number 7. You guys can all see number 7? Oh, somebody's chatting at me. Uh-oh. Yeah, I'm sorry, Leno. I understand. Trust me, man. We're all doing the best we can. By the way, I don't know if you understand me yet. But all you got to do is reach out to me if I'm not offering enough office hours, if I'm taking too long to look at stuff. All you got to do is communicate with me, right? If there's an old homework that you submitted recently that I haven't graded yet, like a section 1-2. So, because I'm kind of working my way through and I forget sometimes to go back in case somebody, just remind me, just say, hey, I just turned in 1-2. You haven't looked at it yet. Just wanted to let you know, right? You guys with me? I'm not going to take that personal. I'm going to appreciate that because I need help keeping track of things now digitally. Are you guys with me? You guys look like me. You're like, I want to go back to bed.
Yes, perfect. Thank
Okay,
you.
all right, I understand. So let's look at this. Read through number 7 real quick. 7's got an interesting twist to it. It's page 80, by the way. You can see that up there. This is section 1-6, that probability stuff. Let's see. Well, I've really not set this up correctly, have I? All right, so write down an answer. Don't say anything out loud yet. Then I'm going to have to shift around a little bit. I'm going to stop sharing for a minute. All right, technology, you suck sometimes. All right, here we go.
So we on page, what page are we on, Jeff?
Page 80.
Okay.
Yeah. Let me see if I can do this now. We can do this, Jeff. You can do it. There you go, buddy. There you go. Yeah, page 80, right up there. Wow. All right, let me make this more interesting color. All right, so has anybody got an answer for me for that one?
Two out of 45.
Yes. So there are 45 people. Out of those 45, how many will get a job? 2. Now, write your answer using probability notation. So that's kind of like what I was doing yesterday. So what would I put in front of here? The probability of what? Just tell me in English. The probability that?
Getting the job.
Yeah, get job. I am job. All right. And go ahead and change this into a percent for me. I think I know what it is. Is it
4.44?
4.44, right? So let's say 4 point. Is that right? 4.44444444444444. Yay! Very quickly. I want to show you something really cool. Just give me a second. This is a little side note. This is very interesting. Do 1 divided by 9 for me in the calculator. What do you get?
0.1 repeating.
Yeah, 1, 1, 1, 1, 1. So what would, and repeating, right? So what would, you don't even have to do this in the calculator, right? You shouldn't have to do this. What's 2/9 then? 2/9 has got to be
0.2 repeat.
2. And then 3/9 would be
3 repeating.
3.
3. And why does that make sense? Because 3/9 reduces to be 1/3, right? And you guys already know that 1/3 is 0.3333. Is everybody roughly with me? Is somebody trying to chat to me? I can't operate. No, thank God. All right. Oh, sorry. It's just too many things to try to keep track of. So I just did, now watch. So 4/9 is 0.444 forever, right? So what is 4/90? It would be, I really want you guys with me. Are you guys still with me a little bit before I do this 4/90? So I'm dividing by 10 more, so I'm going to move the decimal back 1. So what does 4/90 have to do with this problem? Well, 2/45, if I multiply by 2, is 4/90. So that's how I was able to do that division so quickly, because I know what divided by 9 does. And, you know, you could either be really interested in that or not give a shit about that. That's fine. It's just kind of neat. Can somebody point out what is the least, what is the part of this problem that makes the least sense, that is probably not true? That kind of relates to number 8. What statement in number 7 doesn't sound like it's a real life truth?
That every applicant has an equal chance.
Yeah, is this ever true? Is this ever true? Without getting into, you know, a lot of controversial issues that we know exist. Gender problems, ageism, obviously racism, all kinds of reasons that certain applicants might have less of a chance or more of a chance if they're a member of a privileged group, right? You guys with me? Okay, maybe. So that, if everybody had an equal chance, that is everybody's probability of getting a job. So number 8 says, why is this not a realistic way of deciding your chances? Because of what we just said. Not everybody has an equal chance, so not everybody. Jeff, you probably, oh my God, everybody has an equal chance. All right. I think you guys get the idea there. So I can't assume equal chances all the time because we know that very often it's not true. Okay, maybe. Now look at number 9. Can you guys see number 9 down there before I have to scroll up and lose all my writing? Now this one sort of incorporates both 7 and 8. So just doing theoretical work, what are the chances that a student gets a job based on the data that we're given? What are the chances? Out of how many students? Out of how many total students?
480.
Right. Out of 480 students, how many got a job?
450.
450. And that reduces kind of nicely. It should. I don't know what the hell it is. 15 16ths. That's like 0.93. Maybe?
75.
What is it?
0.9375.
Oh, cool. All right. I wasn't too far off. Let me stop for a minute. That was just like what we did up here for number 7. That's exactly the same reasoning we applied, right? There were 2 jobs available out of 45. So this one, there were 450 people that got a job out of 480. The one difference, what is different about number 9 is this is based on probabilities of something that will happen. This is based on something that has happened. Same basic idea, but just one is using what's available and the other one's using what has happened. So this one is actually called, this is not important. It's not something you have to definitely know, but just so you know, this is called empirical. If I could spell, get out of there. Let me try this again. It's called empirical probability. That just means it's based on actual observations, right? This one is theoretical probability. This is theoretical probability. This is empirical probability. This is actually stuff we've observed happening. Let me stop for a minute. Do you guys see the difference between the two? This one, nothing happened yet. This one, everything happened. All right, I like it. I like it. All right, so in order to move this, I have to clear all of my writing, which is probably generally a good idea. Does anybody need something up here still? Okay, I'm gonna say no. Go away. I'm surprised. I'm always surprised when people don't try to write. All of you could have written on there, but nobody did. I appreciate it. All right, let me see if I can move this down. There we go. Now here's another one. Now, we did a problem even a little bit harder than this one yesterday. See right here. Here they use empirical probabilities. So that's when I have actual data that actually happened and that can construct ratios. So here we have actual responses. We have data. They talked to 1,005 people. And here's the results. Take a look at number 10. Don't say anything out loud. Don't chat anything. Just try to answer number 10. Oh, by the way, do you guys see the basic idea here? It's a little bit wordy, a little bit worded weird. But once you start a new job, how long did it take before you realized you could stay there? Now, think back. Some of us haven't had many jobs yet, but some of us, like me, have had many, many jobs. And let me tell you, certain jobs, a week in, I'm like, I don't know. Okay, I got to find something else. And then other jobs, I'm like, yeah, oh yeah, I'm staying here, right? So this is what the purpose of this point is. How long did it take for you to work somewhere and realize, okay, I can stay here? That's what these responses are all about. So what's the probability that somebody knew within a week that they could stay in their long-term job?
$231.
So a probability can't be bigger than 1, right? So it's always got to be something out of something. So 231 out of, that's where you got to do a little bit of work, right? But you don't actually, because they already give it to you. What do these all add up to be? How many total people? Well, they already told me. So 231 out of 1,005. So be really careful. Every time you answer a probability question, your answer cannot be bigger than 1, because 1 means 100%. So if somebody told me there's 150% chance it's going to rain tomorrow, what the hell does that mean? Are they going to be like house-sized raindrops? Is that what that means? It's going to rain so much, it's going to rain in the next universe. I don't know what the shit that means. Right? So give 110%, that's mental. That's not math. That's like, I got to give that little extra bit. Great. But it's not mathematical. That doesn't mean a damn thing in math. So who's got this for me? Where's my calculator? There it is.
0.2298.
Neato. I like it. 2298. Oh, crappity doodah. Come on, Pen. You can do it. 0.2298, which I can make. If I rounded it to the 10th spot, who knows what this would be?
0.23.
0.23,
Yep.
yeah.
So 23%. I like it. Is that right? 0.23. So then I move the decimal once, twice. Let me stop for a minute. So by now, what's funny is, obviously probability gets more difficult, right? These are pretty basic probability problems, but What is the idea of a probability? It's how many things match what I'm looking for divided by how many things it could have been. So what's probably that a randomly selected worker? So it could be 1,005 people that I pick. New within a week. Oh, so 231 match what I'm looking for. So that's the basic idea of any probability anywhere. All right. And so what is this one? Took more than a month. What would you do to figure that out? What's the probability that, or percent chance probability? What's the probability that it took more than a month? How would you figure out that one? Does that relate to one entry?
Would you use the half a year, within a year, and over the year?
Exactly. So again, the top is everything that matches what you're looking for. And there are 3 categories that match what I'm looking for. So how many total match what I'm looking for?
372.
Good. So 372 out of?
1,005.
I gotta get used to this pen. All right. 1,005. And then whatever the hell that is. I'm gonna guess 0.368. 369.
0.3701.
3701?
Mm-hmm.
So about 37%. Is that all right? All right. So good for practicing percentages. Not generally very interesting though, data, but that's all right. We're just practicing percentages. Okay. Does anybody still need that up there? Let me see. Let me do this. All right, I'm going to clear all that. It's going to go away. Let's see. Somebody's still copying. Let me stop for a second. O'Reilly. Okay, here it goes. They're all going away. Bye. Oh, now this one's interesting. I love this one. I have no idea how this book expects you to be able to write this. Write a sentence or two explaining how likely you think it is that your professor decided if he or she could stay in a job long-term in a half year or less. So you could purely use these numbers in a half year or less. You can add these up just like we did for this last one that we did, more than a month, right? You can add up these and divide by 1,005. But the point I think number 12 is trying to make is you know a little bit more about me, so you might be able to put that into the problem also. I have no idea what you would know about me that would help you figure this out, but we're just going to pass 12 on by, right? I already kind of told you I've had jobs both ways. Now, this is a really good question. Here we go. Here's the thing. You guys are bombarded by percentages. You're bombarded by probabilities all the time, and you don't know what to look for. So when I teach statistics, I make a huge deal out of every time somebody says, oh yeah, there's a 72% chance that this is gonna, based on what? Who did you talk to? How did you collect your data, right? It's all about that. So 1,005 people were surveyed. It was done online. How accurate do you think these probabilities are when used to describe the feelings of all American workers? So think for just a minute, come up with maybe a couple things, a couple points about how accurate you think this is and why the accuracy might be better or worse. Oh, somebody's chatting at me. Oh, okay. They do imply that it is 1,005 different people, 1,005 people. And normally when we're doing a survey, we do try to not include the same response. the same person over and over, right? But I mean, that's a decent thing to point out, Andrew. So we're assuming that all 1,005 people are different people. So does anyone have like a concern? Like what would make this survey maybe less accurate or less believable? Anybody have an idea? Anybody? It's almost impossible to have a wrong answer. All right, so I got a chat. Nobody wants to talk to me today. Okay.
Sometimes people don't like taking surveys online.
Yeah, sometimes people don't. Well, so do you say that they don't like it?
Right. So the people that do take surveys can be, I don't know. I guess I can't explain it.
I think I know what you mean. So the people that do respond.
Right.
Good. This is a very good point you're making, I believe. I don't want to put words in your mouth. But the people that don't respond, what might that mean about them? So like you're saying, maybe they just don't like doing things online, right? Now
they don't want their data harvested.
Say one more time.
They don't want their data harvested, which is what I assume these surveys usually are when I see them online.
Yes. So in this day and age, especially, a survey is never just a survey. It's always trying to collect your email, your phone number, get a donation from you. Yeah, exactly. That's another concern. But let's say that, but actually that ties in, I think, to Vu's point. What is wrong if there is a certain segment of the population that would never answer a survey like this? What does that mean about the results you get?
Inaccurate.
Yes, because are you representing everybody's opinions?
Right. It's not it's not everyone. It's not a complete picture.
Yes. So is anybody concerned about the size of the survey? I think somebody privately chatted this to me. This is actually a very good size survey. Very good. And a lot of students have trouble imagining that, because does anybody know how many adults are in America right now?
No.
It's in the 200 millions, right? There's 340 or 50 million people. There's like 200 something million adults. You guys with me? And so when they see 1,005 people were talked to, they're like, how the shit? But that's beautiful. This is a very, in fact, there's a website called gallup.com, and they're an excellent polling website. And their groups are normally in the 1,200, 1,500, somewhere in their range. Statistically, that is a very, very, very good sample size. And this is such a weird thing for people. Does anyone have an issue with that? It's fine if you do. In fact, you almost should. So, like our class has, let's say it's got roughly 30 people here right now, I think. I can't see it right now. If I surveyed, 2 people, is that good? No. If I surveyed 8 people, no. But do I have to survey all 30 to accurately represent? No, I don't. I don't need to have everybody to have a decent feel for the whole class. I just have to pick a random group of something. So 1,005, as long as it's chosen randomly, is fine. Okay, so that's one thing. Vu, let me see if I can capture this. This is actually what's called a voluntary, let me just go ahead and get really technical for a second. Voluntary response sample. And very often the responses you get are from people that have very strong opinions. And very often those strong opinions go one way more than the other. So your results would be skewed in that direction. Does that make sense? So that's a beautiful thing to realize. I love it. Anything else? Go ahead, say.
So what would an involuntary response to a survey, like the census or something that you legally have to?
There you go. That's a very good example of it.
Oh, okay.
Most surveys are voluntary response unless it's something with a legal mandate like the census. Exactly. So it's very difficult if you mail out 10,000 surveys and then wait for some to come back. It's almost always going to be biased. You with me? In fact, nowadays, if you see an online poll, you have to stop and think, okay, what website is this? What kind of people normally come to this website, right? Yes, with me? So if you look at an MSNBC poll versus a Fox News poll, and to be really honest, Fox News polls are actually really good, which kind of surprises me, but still, it has a very good rating. They actually do a good job with that. If only they did a good job with everything, but their polling is good. So much for keeping my politics out of things. Let me see. Anything else there? That's the big one, because that is the big one. Voluntary response. I already addressed that the sample size is good. What's one other thing about this fact? Not just that people don't like it, but
It's online, yeah.
it's online. And does everybody across America have the ability to go online?
No.
No. And maybe their opinion goes one way more than the other. So then your results end up biased, end up skewed in one direction. Okay, good. So this is kind of laying the groundwork for you guys to realize one level of statistics is, do you understand how to do the mathematics? The other level is, do you understand, even if you do all the math right, there are reasons your data could have been bad in the beginning. And so you can't trust your results. So that's why anytime you see data being presented, they have to tell you at least how many people they talk to. But then they should also tell you how they picked those people, right? So if I'm like, well, 38% of Americans want to vote for this guy, I'm like, who did you talk to? People from my town in Wyoming. What the shit? That doesn't represent all of America. Get out of here, right? So you have to be told how many people and how you pick them. That's the very least they have to tell you. Okay, that's enough of that. I think I've beaten that horse a lot. Oh, and then Joel's got a really good question. This is really nifty. If you get into like higher level statistics courses, there are a couple courses that are about how to design a survey or even a phone conversation. If you're calling people and asking questions, that will tease out if somebody's telling the truth or not. So they try to build into the survey various methods to answer Joel's concern, which is always a concern, right? You always got somebody who's like, let's just make something up and screw them all over. So that's a very good point, Joel. Okay. I think it's enough of that one. I beat that one to death. Let me see. I'm going to clear all my little scribbles. Oh, and then I got to do this. Oh my goodness, so much technology. All right, and that's the end of the group work. Let me look at I want to show you what the what do you call it? Homework is going to look like for you. They had a very similar question to this earlier that we looked at. Somebody asked me a question about these two. This is kind of, again, this is very interesting. You can calculate how many you would expect to be female in the Congress, and then they tell you what the reality is. Now, to be honest, I didn't look up, I don't know what year this was done. I don't know where we stand right now as far as how many women are in Congress, but at least this is relatively recent. So again, I just want to show you that the questions don't get too crazy, and they are kind of very similar to ones we did together already, just to give you an idea of what to expect. And this is a relatively short section too. This has only got 6 questions. Not too bad.
7.
All right, 7, sorry. If only I could count, my job would be easier. I want to look a little bit ahead, unless there's any questions left over from section 1.6. If anyone started that yet, no. Want to look a little bit ahead today. Oh, good. Okay, let me see. Get back here. This book is so touchy. So does everybody, so how would I analyze 10 to the 7th? How would I, they give us the answer there, but why is that the answer? How would I do 10 to the 7th? What does that mean to do?
Multiply 10 by itself 7 times.
Yeah. So I have to write 10 times 10 times 10 times 10 times 10 times 10 times. I think that's 7. Yeah. Now 10 is beautiful. 10 is the kick-assist. Can I make a, screw it. It's an excellent number because our number system is based on 10. So 10 times 10 is 100 times 10 is 1,000. So do you see the shortcut would just be, how many zeros would there be? 7, right? So you can see right here, there's the answer, 1, 2, 3, 4, 5, 6, 7. So 10 to any positive power is easy. So here, can you guys do 10 to the 5th? Can you write down what that would be?
5 zeros.
Yeah, you got it. So it'd be 1, 1, 2, 3, 4, 5. So you got 100,000. I like it. Now here's where things get freakier. We have not discussed negative powers yet. So what the hell would a negative power mean? I mean, they kind of show you this. Why does this make any sense at all? So let's try to make some sense out of this. Okay, you ready? So help me out. Somebody help me out here. What do you do when you have this? What do you do if you're doing this? Does anyone know?
You add the powers.
Yeah. That makes sense because x squared, let me just, you never do what I'm about to do, right? But this is just to show you. X squared is 2x's multiplied times
3x.
Another 3x's. So of course I have
5x's.
5x's connected, right? And I always get somebody tell me, but Jeff, 2 times 3 is 6. And let me tell you what I tell them. You ready? Somebody tell me if you think I'm insane. There is no 2 or 3 anywhere in here. Nowhere in there is there a 2 or 3. Nowhere. And you're all like, dude, I already knew you're insane, man. What does that represent? That there's 2 x's. There's no number 2. What does that represent? That there's 3 x's. There's no number 3. So there's no 2 and 3 to multiply. There's just 2 x's sitting next to 3 x's. So of course you got 5 x's sitting together. Does that make sense?
Yeah.
Sort of? All right. So now watch this.
No, question. I got a question. Do that dot represent multiply?
Totally. And of course, I can't, there's very few instances where I can use an X to mean multiply, because if I did that here, it actually looks like there's how many X's? 2, 3 more, and 1 more. So I can't use an X as a multiplication in this kind of problem at all. That wouldn't make any sense, right? So I can either put a dot or I can put parentheses, right? Or to be honest, since they're both variables, I can just put them next to each other. If my pen would work, come on, pen. Yeah, I could just write it like this, x squared, x cubed. Because I know that sitting next to each other means multiply. All right, let me stop for a minute. You guys, does that make sense right there, what we've done so far?
No.
Okay, now watch. Oh, sorry, go ahead.
Okay, so you're saying because they are not numbers, then you automatically just add them up.
We add them up. So the reason I took a minute to explain that there's no 2 or 3 here is so that you'd see that 2 times 3 is 6 doesn't make any sense. There is no 2 and no 3 to multiply. Right. So I am multiplying stuff. So if I have x cubed times x to the 4th, it isn't 3 times 4 because there is no 3 and 4. There's 3 x's, 4 x's. So of course there's how many?
7.
7. So that's my point for saying that.
Right.
I'm hoping that helps. Because your brain says, I see multiplication and I see a 3 and a 4 and I know that's 12. fight me, right? And you're like, brain, calm down.
Yeah, my
I don't
brain
see
was a dot. The
Oh
multiply.
yeah.
Yeah.
So I could have written this like this also, just sitting next to each other, but that's acceptable, but it's, to me, I like putting the dot in there just to make sure everybody knows what's happening. All right, now, here's my point, because the whole problem was negative powers, Jeff. So what are you talking about over here? You're talking about bullshit. Okay, give me a minute. What would this be over here now? X to the 5th divided by x squared. What would that be? So what does x to the 5th mean?
X times
I-
X times X times X times
X times X times X times X times X, right? And what does x squared mean?
X.
2x.
So what happens here?
They cancel out and you get X to the 3rd power.
Yeah, you get 3 x's left over, right? So effectively, what did you do with 5 and 2?
You subtract it.
I subtracted them, exactly. Kick ass, right? 5 minus 2 is 3. I had 5 x's. I divided 2 away, so of course I got 3 left. And it kind of makes sense. What do I do when I multiply over here? What do I do when I multiply? I add the powers. What do I do when I divide? I subtract the powers. Isn't that beautiful? The symmetry there. You don't have to use the word beautiful. It's okay. So again, what the hell is my point? Well, watch this. So x to the 5th over x squared is x cubed. Is everybody decent with that? And again, please don't do this, because what if I would have put x to the 50th up there? Don't put 50 x's and start so please don't do that. Now we know we subtract here, right? Now watch this. What is x to the 5th times x to the negative 2?
The same thing.
Yeah, because what do I do with the powers? When I multiply these like bases, I just add them. And what is 5 plus negative 2? 3. So what does a negative power look like it means? A negative power means flip that thing. Oh my God, Jeff. So let me see. I should make some blank spaces here. So really, now watch. I want to show you why this makes sense, and then we'll talk about the shortcut, okay? Some of you guys know there's a shortcut involved here, but I really want you to understand why this makes sense. So what is 10 to the negative 4th? It'll be 1 over 10 to the 4th, because a negative power just means flip that thing. That's all it means. Can somebody help me out? What the hell is 10 to the 4th using what we did up here?
10,000.
Yeah, it'll be 1, 2, 3, 4. So 10,000 exactly. Now, what places did they put this? What is 1 over 10,000 written as a decimal? Well, it's tenths, hundredths, thousandths, tenth. Sure enough, that is this. So here's the shortcut that I think some of you guys know. When it's a negative power on the 10, you take the decimal back 1, 2, 3, 4 places. So when it's a positive power, do you see how I actually move it over 1, 2, 3, 4, 5, 6, 7, which translates into 7 zeros. When it's a negative power, I take the decimal and move it 1, 2, 3, 4. So the shortcut is, how many zeros are in front of that 1? 1 less than that. Go ahead. Go ahead. Anybody? Somebody start talking.
No, I'd say a 4. I'm just counting with you.
Yeah, and I'm not counting that 0 there. Just how many decimal places are there? There's 1, 2, 3. And then, of course, the 4th one is this one, around the 1. So if I had 10 to the negative 7th, the way I would do that is put 1, 2, 3, 4, 5, 6, and then a 1.
Jeff, it only works that simple with zeros, right? Or
It only works that simple if the base is a 10.
Right.
which should make sense because working with 10 has to be easier because our number system is based on 10 for some reason. I don't know. Now, some of you guys might know where this is headed. This sounds like it's going towards something called scientific notation. I don't know if anybody has ever heard of that. Scientific notation. Okay, some of you guys have. So let me. In order to scroll, I got to lose all this chicken scratch, which is probably a good thing. So let me know right now if you need some of that chicken scratch up there still.
So I have a question.
Yes.
So if it's 10 to the 4th power, you're going to times it. And if it's 10 to the negative 4th, you divide it?
Exactly.
Okay.
So to be really honest, here's where we're going. This is what's understood to be out here is a 1.
And is that why the 1 is over the 10,000 in the problem?
And that's why there's a 1 here, and that's why there's a 1 there. And yeah, that's why there's a 1 there. Exactly.
Okay.
Where'd that 1 come from? It's just understood. In fact, what's in front of an X? There's a 1 here. There's a 1 down there. There's a 1. Holy, there's so many understood 1s when I write something. So let me make this, let me push this a little bit. 1 times 10 to the 4th. So it's going to take the decimal and move it over 1, 2, 3, 4. So that means I'm going to have 1, 2, 3, 4 zeros. 1 times 10 to the negative 4th, I'm going to move back because it's a negative power. So I'm going to move it. So the decimal right now is right there. 1, 2, 3, 4. That's why I end up with 1, 2, 3 zeros because I have to move it 1, 2, 3, 4 places. So here's kind of like the next level to this then. Let me at least change the color, Jeff. What do you think? Yeah, I guess I could try to make it. So look at this problem. What if I had 3 times 10 to the negative 5? So I know I have to go back 5 places. So I write a 3 and I go back 1, 2, 3, 4, 5. So there's a 3 there because there's a 3 there. So this kind of controls what place I'm in, and then this controls what I put in that place. So if I had, like 7 times 10 to the 4th, that would be 7 followed by 1, 2, 3, 4 zeros. So 70,000. So the reason that these examples have a 1 here and a 1 there is because there's an understood 1 sitting out in front of this thing that's getting moved around. And again, this is a preview. We're going to get deeper into this next time. That is a lot of a mess up there, but okay. So I'm going to clear all that. Now, okay. And so you can see they get into, what if it's not 10? What do I do? Same kind of stuff. It works the same way. It's just, is this easy to write what the answer is for this? 12 to the 5th. Why is that harder to do than a 10? Because 12 times 12 times 12 is not easy. 10 times 10 times 10 times 10 is just moving the decimal place. 12 times 12 times, holy shit, now I'm doing different numbers and things are getting crazy. You guys semi with me? It's always easier if the base is a 10.
Right.
But the rules don't change. A negative power means flip. So 3 to the negative 4th is 1 over 3 to the 4th. And then I can write it out like this, right? 4 3s. Here's that idea of adding powers, right? I have 3 12s times 6 more 12s is, of course, 9 12s. So one mistake people make, let me see if you guys get this. 2 cubed times 2 to the 5th. What would you tell somebody? This is wrong. I'm about to write the wrong answer. 4 to the 8th.
No, the base stays the same.
Yeah, why? Because if somebody writes this, here's what I'm going to write. Here's what I'm going to write. I'm going to write, how the hell do you get 8 4s? I don't see any 4s. I see 8 whats?
2s.
Yeah, so it should be 2 to the 8th. The bases are the same. The bases stay the same. Because it's just 3 of these, and then times 5 more of these is, of course, 8 of those. It stays the same. You guys get that? So that's why this is still a 12, not something else. It's 5 12s. Okay, maybe. So we're taking a little bit of a step into, some higher level computation stuff. All right, let me see. I got to clear this now so I can keep going. Here we go. Cool. And here's what we talked about earlier. Oh, somebody's chatting at me. Oh, beautiful. Okay, I love it. See, this is the kind of question I live for. So Ruben says, well, he doesn't say this, but I'm going to pretend like he said this. All right, big deal. What the hell? What if it was different bases? All right, so what if I had 7 to the 5th times 11 to the 4th? Do I have 9 of anything?
No.
No. Yeah, perfect. So can I do something with this? No, not really. Unless I throw it in the calculator, which who cares about that? Right? I know the calculator can do shit. Can I do anything with this as a human? No. If it was 11 to the 5th times 11 to the 4th, now I can do something. Can I? What is it?
9 11.
11 to the 9th. Kick ass. So I got 5 of these, 4 of these, so now I got 9 of these. I love it. Here I got 5 of these times another 4 of something else. Oh, okay, well, all right. So they have to be like bases so that I can consolidate. It really is just consolidation. If somebody came over to me and said, I got 5 chairs and 7 chairs and 3 chairs, I'm like, just tell me how many chairs. Just put all that together, please. You guys with me? But if I had 5 chairs and 3 tables, do I have 8 chair tables? The shit's that. I got 5 chairs and 3 tables. I can't consolidate that, right? And maybe. All right. And this, like I said, this is just the same idea, except when I divide, I subtract. So what is 15 to the 9th? Can I make a 9? Divided by 15 to the 5th.
15 to the 4th.
14.
15 to the 4th. Exactly. When you divide, you just subtract. Because when you divide, you're losing that many 15s. I had 9. I divided 5 away. So, of course, I got 4 left. Of course I do. That's all exponents do. That's what they're based on. All right. I'm going to clear that little bit of mess there. So that was a good question, Ruben. Did that make sense? I'm going to assume.
Wait.
Yes.
Can you hear me? Oh, okay.
Yes.
Basically, all you did was on that 15th problem, you just 9 take away 5, ended up with 4 15s.
And I really, I really want this to make sense.
To the 4th power.
Watch. Yeah, and let me show you one more example of the long way that we'll never do, right? If I had 7 to the 5th divided by 7 cubed.
Right.
7 to the 5th is 5 7s, right? Divided by 7 cubed is 3 7s. Don't I lose 3 of them? Right? Don't I cross through 3? Yes.
Right.
Which is exactly the definition of subtraction. I had some amount, I lost so many, so of course I subtract to see how many I've got left. I really wanted to make really good sense why a division problem suddenly involves subtraction. It is because of this. It is because exponents keep track of how many of these things I have. When I divide, I lose some of them. Because as a student, it should be kind of weird that a division problem involves subtraction to get the answer. But you can see why. It's because of what the exponent represents. I lose so many, so of course it's going to be subtraction to get that. That's the idea of subtraction.
I guess the word divide is kind of like subtract anyway, right? You like split.
Sort of in a few ways, but you got to be careful about that. But what I hate is when I teach this and then I give somebody this problem here and they tell me the answer to that is 8. Right? So I teach this idea and then I give this problem and they say it's 8. Of course it's not. Are there any exponents here? No, not really. I mean, there's ones, but these are actual numbers. So it's just 10 over 2 is freaking 5. I mean, that doesn't change. So this is a really good place for me to remind you guys, anytime you think that something we've done before is now different, talk to me, because that's impossible. Math cannot change what it's already set. We just learn other and other things. We're learning how to exponents deal with division. They're not going to be the same because they're different beasts, right? Maybe. So watch this. I want to show you an example. What is, let me go up here for some blank space. What is 27 divided by 9?
3.
3, okay. So isn't 27 3? What is 27? 3 to the what power? How many 3's do you multiply to make 27?
9.
No.
3 to the what power?
What's 3 times 3?
9.
Times 3? 27. So how many 3's does it take to multiply to 27? It takes 3 of them. Yes. And of course, 9 is 3 to the what power? Second power. Is everybody with me? I'm not saying do this problem like this. I'm just showing you how what we learn matches with what we know. We know the answer is supposed to be freaking 3. So if I rewrite them, I better still get 3. And what do I do with those powers now? The way I've written it.
Cancel them out.
Yeah, 3 minus 2 is 1. So I do get the answer is 3. If I rewrite the numbers in exponential form and they have the same base, I could use this and it's going to come out to be the same. It has to come out to be the same answer. It's just when it's in exponential form, the rules are changed a bit because they're different creatures. How do these creatures deal with division? You subtract the powers. How do these creatures deal with division? Well, you just divide. What do you multiply this by to get this, right? So it's kind of a different way to think about the problem. How are we doing out there? You guys tripping out? Okay. All right. And again, this is our first little step into this. We're going to do more with this. Let me see. Let me clear this. Anybody still need this up here? You know, like, I didn't need that up there in the first place, Jeff. I'm like, I know. I'm going to clear it. Okay. Oh, and then here's your actual problems that you have to do. Now, this is an interesting one. Look at number 6.
Hey, Jeff.
Yes.
When it says evaluate, can you go back up? Right there, sir. Thank you. So number 1, it says evaluate 10-5.
It just means simplify it. It just means do it. And that's exactly like the
you would times 10. You would times 10 times 5. That's it?
Definitely not.
No, definitely not.
Definitely not.
That's, I'm confused.
Because this doesn't say 10 times 5. What does this say?
Size 10 to the 5th power?
Yes. Yes, which would be 10 times 10 times 10 times 10. And that, again, is...
And that's our answer?
No, because you haven't simplified it yet. But here's the shortcut. Remember the shortcut we just went over. If I have 10 to the 7th, I just put 7 zeros. Why is 10 such an easy base? Because it matches with our number system. Our number system is based on 10. So when you have a base of 10, you should go, oh, thank God. That's going to be simple.
And if it's not a 0 number, it's an odd number, what would it look like? Would it be different?
Yeah, so if it's not a 10,
Yeah, if it's not a 10, and let's just make it a non-number. Let's say, all right.
like here, right here, right? 12 to the fifth is 12 times 12 times 12 times 12, 5 12s. That's what a fifth power means, is that many things multiplying.
And that's the answer. That would be when it says evaluate 12 to the fifth power, our answer is 12 times 12 times 12 times 12.
Not really, because you still haven't evaluated it. If the problem was evaluate 12 to the fifth, you would put that in the old calculator, 12 times 12 times 12, and get the number. Evaluate means simplify. It means do all the operations. So you wouldn't just write 12 times 12. You would actually then put it in the calculator and see what number that is.
Thank you, Jeff. Thank you.
You're welcome. Okay, so these are ones to try out on your own. And it's getting us ready for this next section. Yeah, we're going to be talking about debt. That should be nice. Because, of course, I was going to bring this up earlier, but it's definitely not this anymore. It's definitely higher than this. Our national debt, the amount is kind of hard to wrap our brains around. How much debt we have. And especially after the pandemic now, I can't even imagine where our debt is at the moment. I don't want to look. So here's that thing I was talking about. This is full-fledged scientific notation. We will be getting into that next time. Do you guys remember what's happening on Monday?
Holiday, I guess.
Yeah, it's a good guess. It's better than saying a quiz. So Monday is Labor Day holiday. So to celebrate Labor Day, we don't labor. So it sounds very American. I like it. So enjoy your Monday off. So in my Zoom links for next week that I'm going to post, Monday won't be there, obviously. So that'll be a big reminder. Otherwise, I'm going to go ahead and say that class is over. And if you want to stick around, have questions, let me know. Otherwise, you may roam around your house.
Okay, Jeff, I'm on. Got something for you. Can you hear me?
Yeah. Yes.
Okay.
Thank you, Jeff. I'll see you next class.
Okay.
I have to go. Thank you.
Okay. Yeah.
Okay, so I'm getting into this evaluate thing. You said we're doing the prep skill questions too, right? I got some notes.
Yeah, it's always a part of the homework. Yes.
Right. So we're going to the prep skills first on this 1-7 rather.
Well, this is a part of 1-6 homework. Yeah. So when they say, whenever you see the word evaluate, that just means do all the operations. So a normal problem that you might be more used to seeing this is if it said evaluate 8 minus 10 times 3 plus 2, right?
Yeah.
So that word evaluate, pretend like that's the word evaluate. Good Lord, Jeff. That word evaluate just means do all the operations. So if you just wrote this, you're not right because you haven't done the operations yet. And we know a shortcut for doing this. So you don't actually have to do this, right? We know the shortcut now. So evaluate means do all the operations. That's all it means.
Okay.
So if I write this, I'm just saying, this is the stuff I would have to do. And I'm like, well, it said evaluate it. Do it. Don't just tell me what you got to do.
Put my 1 and then my shortcut for the 10s is the 5 zeros and call it today.
Exactly. Which is exactly what 10 times 10 times 10 times 10 times 10 is. I like it.
And same thing for the subtract.
Okay. Anything else, guys? Oh, sorry.
And so,
are you having the Thursday?
2 to 3. Yes. I think it's 2 to 3, right? Yeah, 2 to 3 today. I'll be there.
Me too. Thank you.
All right. I'm going to head out. I'll see you guys, maybe some of you guys later today. Otherwise, Tuesday. Bye.